Let's erase that. Okay. So how do we actually solve graphically? That's what we want to do. Okay. So this question they told us, again, 3 adults, 1 child was $11. And since X was the price of an adult, Y was the price of a child, we got this first system here, first equation in the system. 3x plus y equals 11. And then they go on to tell us that 2 adults and 3 children were $12. So 2x plus 3y equals 12. The first equation, in order to graph on the paper, we need y by itself. So what did you do first? Minus 3x, we're moving it to the other side. So when you move it to the other side, it's going to be the opposite sign because you're doing the opposite operation. So to plot that, tell me what you know about that graph. Y-intercept is 11. Good, so we can plot that point. What else do you know about this graph? Slope is -3, and if I want to make -3 a fraction, how do I do that? -3/1. So what direction would you move? Down 3, and this is a positive 1, so right 1. We always should be always moving right. So down 3, right 1. Down 3, right 1. Down 3, right 1. And there you go. Okay? If you need a ruler, you can borrow one. Use your calculator lid or just roughly sketch it. For now, hate roughly sketching things. Blue. Okay. Okay, so there's the first line. The next one was 2x plus 3y equals 12. First step. Subtract minus the 2x. We want to move it to the other side. Well, y by itself. Opposite operation. Landon, what would you do? Come on. Divide everything by 3. So the equation is 3 x plus 4. Okay, tell me what you know about this graph. Y-intercept is 4. Okay, so let's plot 4. 1, 2, 3, 4. Slope. -2/3. So we're going to go 2 down, right 3. 2 down, right 3. Boom! Look at that. We know our answer. Down to right 3, down to right 3. And let's draw that line. Okay. So what would be the solution to this equation? Someone said it. 2, 3. X is 2, y is 3. 2, 3. So in the context of this question, what does that mean? Because this is actually a contextualized problem. It says the coordinates, the solution was 2 and 3. So that means x is 2 and y is 3. But that's great if it's just a graph. This actually has a context. What did x stand for? What did x? What about the adult? The price. So the price per adult ticket is $2. Yes. Sorry, guys. It's really bad when your teacher does dyslexic things like that. Let's try that again. X coordinates 3, y coordinates 2. Would you agree with that? Yeah, thank you. I'm sorry. So it's actually price for an adult, which makes way more sense. An adult should be more expensive, right? The price for a child, price per child is, that's why we use pencil in math, $2. That's better, okay? All right, let's look at the next page. I'm going to show you how to use your graphing calculator right away. How to solve these your graphing calculator. Nope. Okay, really quickly, I'm just going to talk about what they're saying on the next page right now. So all of these red dots that I put on the red line, okay, all of those coordinates, every point on that red graph, red line here, satisfies that equation. Anything on that line satisfies it. Anything on the blue line, any of those blue points, satisfy the blue line. The solution is the one that satisfies both equations, which is why it's the point of intersection. Right? So just the point 3 and 2 will satisfy both, will be on both lines. That's really what they mean by satisfying. I don't know why they have to use that word, but they do. And so that's what all of this is saying here. So we can move on to example 1. Okay? That's what they're saying. A system of equation has been represented on the grid. The system has an integral solution, like integral solution. State the solution. So if it's integral solution, it's saying they're integers. So what would be the solution here? What is this point of intersection? What's x here? 2, and y is? Nope. Careful. -1. So that would be the coordinate of 2, -1. Okay? All right. How are we doing for time? We're okay. Not great. We just did this. But I want to do this. Okay. Let's do this together quickly. So solve this by graphing without technology. We're going to graph by hand. First step on that first equation. Convert it to y equals, so we have to move 2x, and it's going to become, we subtract it to the other side, right? We subtract it, so it becomes -2x plus 2. Y-intercept, 2. So y-intercept is 2. Slope is -2 over 1, meaning we're moving down 2 and right 1. We want to fall to the right. So keep following that pattern, down 2, right 1. Sorry, excuse me. And draw that line. Especially if you're graphing by hand, you really want to do a good job at drawing that line. So you don't want to make a rough sketch because you need to see that intersection point. Okay, next equation. First step to getting y by itself. Move the x. So x equals, no, -3y equals 15 minus x, or -x plus 15. Okay, because we're subtracting the x to the other side. So we're going -x minus x. And we like to put the x first. Last, we have to divide everyone by -3. What's the coefficient of x if you don't see it there? It was a 1. Okay? So that becomes y equals, not 3x, x divided by 3, or instead of writing x divided by 3, no, 1 over 3x. We like to, x over 3 is the same thing as 1/3 x. It's the same thing, x divided by 3, but we like to see that slope separately from the x. And then minus what? 5. Okay, so y-intercept, -5. Slope, 1 over 3. So we're moving up 1, right 3. So this would be up 1, right 3. Boom, we found the answer. We drew everything nicely. If we're going to go the opposite direction, then both switch directions. So instead of going up 1, right 3, down 1, left 3 would also work. 2 negatives. Down 1, left 3. 2 negatives make a positive. All right. Draw the red line through there. Okay. So what's the solution to this system? What's the solution as a coordinate? Please help me, because last time I couldn't read a graph. 3 and -4. Now, how do I algebraically verify? We always use the original equations. So I have to sub in 3 and -4 into both equations and prove left side equals right side. Okay? So first for the equation, we always use the originals. 2x plus y equals 2. 2 times, what was my x value? Was 3 plus -4 has to equal to 2. 2 times 3 is 6 plus -4. 2 equals 2. Check mark. Okay, we're proving left side equals right side. We're just subbing it in. The other equation was x minus 3y equals 15. So x was 3 minus 3 times, and y was? What was y? -4. We're using our solution. And when you, so -3 times -4 actually turns into plus 12. Does that equal 15 then? Yes. So it satisfies both equations. It's a point on both lines. Okay? All right, I know it's long, but we need to, we're just going to do the graphical stuff. How do you do this on your graphing calculator? Okay? It's not much different. First step is the same. You still have to make it y equals, because you can't punch it in unless it's y equals. Okay, so this is all the steps. I'm going to take you through it. If you need to go through step by step later at home, because you forget, it's there. All right? So let's go back. This is at the very beginning of the lesson, we did this same example. We already made these each y equals. Okay? So the first equation we made y equals -3x plus 11. Okay? So we reroute. We already did this. Make it slope-intercept form. Y equals mx plus b. Okay? The second equation we made already was -2/3 x plus 4. Do you remember that? Okay, so grab your graphing calculators. So first step is the same whether we're doing it by hand or we're doing it on our graphing calculator. We need to make it y equals. Grab your graphing calculators. I'm going to detach my pencil. All right, so what do y equals? Share what's there. And type in both equations. So I can't see mine. -3x plus 11. Make sure you use a negative sign and not the minus sign in front of the 3. And then second equation is -2/3x plus 4. Okay, that's what you should be typing in into y equals. If your windows are weird, how do we reset them? Zoom 6. I'm going to do that because mine are weird. Yours might be fine. So if you push graph, If it doesn't look like this, can you please push zoom 6? If your calculator gives you an error, put your hand up. Okay, pause the video. Okay, so second trace. So see this calc? It's in blue letters, or yours might be different colors. Just calculate. We want the calculator to calculate the intersection point. Second trace, and the only one that's an intersection is 5. Okay, I'll be right there. Okay, so number 5 is what you want to push. So it says first curve. Now, with lines, how many intersections are there? There's going to either be 1, or they're parallel lines, so none, or they're identical lines, so infinite. Those are our 3 options, okay? Usually, it's 1. Okay, it's rare that we have parallel lines or the same line. So usually there's 1. So what it's asking you to do is, like, if you have more than 1 intersection, like, which is what we did in Math 20 today, we had a quadratic and, say, a linear equation. If you have more than 1 intersection, you have to tell the calculator which one you want. You have to scroll over to the one you want. Now, because there's only 1, the calculator is going to just find that one. So you don't have to scroll over to the intersection point like this, okay? You can just push enter 3 times. So where it says first curve, push enter. Second curve, push enter. Guess, again, just push enter. And it'll say your intersection is 3 and 2. Okay? I'll be right there. Okay, state the suitable windows. So you have to see your intersection. If your graph looks like something like, here's my windows of my calculator. Say we have 2 lines, and one line is here, and one line's here. Your calculator won't find the intersection because you can't see it. You have to zoom out so you can actually see the intersection point. Okay, that's basically the importance of windows here. So the solution was 2 and 3, which was the same answer we got on the first page, right? We did it by hand. Or was it 3, 2? Oh, I did it again. Oh, sorry. There you go, 3, 2. Okay? All right, so looking at the next page, let's try one more. Now, if your calculator or your equation doesn't have x's and y's, that's okay. We can just turn them into x's and y's, right? And then turn them back. So, for example, let's make, well, what do you want to do? Who do you want to make x? A? Sure. So let's rewrite this as 6x plus 7y equals 5. And then this guy would be 3x equals 14y. In order to graph this on our calculator, though, we still need y equals. Okay, so first equation, I have 6x plus 7y equals 5. First step, subtract the 6x. We're going to move it to the other side, so it's going to become negative 6x plus 5. Opposite sign, because you're subtracting it. Then, divide everything by 7. Oh, that's not red. Y equals negative 6 over 7x plus 5 over 7. So that's one equation. That's the first one. That's ready to go in. Now we want to do the other one. 3x equals 14y. How do I get y by itself? Divide both sides by 14. So y equals 3 over 14x. So here's my 2 equations. 1, 2. So let's type those both into our graphing calculators. Now, you will get the same answer if you made x is your b value and y was a. You'll get different graphs, but the same solution. Okay, so it doesn't matter who you make x and y. The graphs might look just a little different, but you'll still get the same intersection. Okay, so graphing calculators. Let's do the 1 for now. Go to y equals. It doesn't matter who's your y1, who's y2. Negative 6 over 7. Make sure you use the negative symbol, not the minus there. And then if you're subtracting something. Oh, and don't forget x. That happens. 5 over 7. And this guy, 3 over 14x. Okay. So something like, move down here. That. Okay. Then push. Graph. So do the regular windows work? Let's find out. Can we see the intersection point? Sure can. Rough sketch. One looks like that. Sort of. Should have been a little higher. One looks like this. Blue. And okay, so that's a rough sketch. Okay, so let's use our graphing calculator to find the intersection. What do I push? Second trace, 5, enter, enter, enter. Now, it says you find it as an exact value. Now, what happens is automatically, when your calculator finds an intersection, it stores x and y. Yay, that's a good thing for us. Because, okay, I have no problem turning 0.6 repeating into a fraction, right? What's 0.6 repeating as a fraction? Or do we have a problem? Maybe we do. Anyone? 2 over 3. Yeah, 2/3. Like that one's no problem. Now, do you know what 0.14285714 is as a fraction? Probably not. So, how do we do that? So automatically, if you push x, it stores it as that number now. As soon as you find a new intersection, it's going to change to that new answer. So you can push x, math, enter, enter. And it'll change it to a fraction for you. Okay, yeah? Pardon me? Try one more time. The second trace 5, enter, enter, enter. You typed in the equation wrong. No, try it one more. Oh. Okay, so x is 2/3. 2/3, comma, and y is, so go, where's y? Alpha 1. Alpha 1 is your y value. It's an alpha 1. So you have to push, it's the green, well for me green. Alpha 1, math, enter, enter, is 1 over 7. Okay, so I'll do it all over again. So graph. Here's my graph. I push second trace, 5 for intersection, and then I push enter 3 times. 1, 2, 3. It'll say intersection. Okay? Then, oh no, I want a fraction, because those are ugly decimals. So I quit. Second mode. Girls, stay with me, okay? I type in x, math, enter, enter to change it to a fraction. Alpha 1, math, enter, enter to change it to a fraction. There's my x and y. You can even check your answers with this now. Because you found it on your calculator, you can verify on your calculator too. We're gonna verify algebraically, but we're also gonna verify with our calculator. So with my calculator, my original equations were 6x, so 6x plus 7 alpha 1s, 7 y's, right here. X's and y's. I use x's and y's because that's what my calculator used for the intersection. And that should equal 5. It does. And the other equation was 3 x's has to equal to how many y's? So 3 x's have to equal to 14 alpha 1. 2 equals 2. It does. Okay? So to verify the solution, this is the last bit of our lesson. We always sub it in to the original part. Now, in this question, it was it's actually not x and y. right? So it's actually A is equal to what? Ooh. A is equal to what? 2/3, and B is equal to 1/7. And so I can now verify that solution. So I plug it into both equations. Oh, equals. So I'm going to verify with both equations. 6 times 2/3 plus 7 times 1/7. Did I actually already type that in my calculator? I did. So do I know that this equals 5? I do. I just have to show my check because you're going to get marks for your check and you're verifying. But you can type it in your calculator and just show me, okay, left 5 equals 5. I'm happy. This guy, 3 times 2/3 has to equal to 14 times 1/7. What was 3 times 2/3? What did your calculator give you? Yeah, 2 equals 2. 10. Whew. So we're done. We survived 2 lessons, okay? Circle the following. Number 2. So number 2, then 3A and C. 3AC. 4A and C. 5, 6, and 7. 5, 6, 7. And then your handout. Okay? And specifically the part of the handout that I really want you to do is practice writing those systems, those equations, the word problems. Okay?